Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Today I will be talking about catalysis of different for water and hydrogen production. Today, the base would be article published in recent number issue of biofuel production, hydrogen production, and water remediation by photocatalysis, biocatalysis, and electrocatalysis. The work is published under a group of three universities of Mika Sinampa from Tiep, from Helsinki University, and South Africa University, from Naval Island in Belfast, and of Professor Osman and Professor Mushtapat from Russia. So group of Malaysia, China, India, and Oman scientists. The work is entitled Biofuel Production, Hydrogen Production, and Water Remediation by Photocatalysis, Biocatalysis, and Electrocatalysis. The work is about how it changes the on recent achievements for energy production and cleaning water and producing biofuels and other green chemistry materials for circular economy. Common catalysts include biomass-derived materials, metal-organic frameworks, non-noble metals particles, nanocomposites, and enzymes. Structure characterization is done by Brunner Emmet Teller isotherm thermogravimetry, X-ray diffraction, and photoelectron spectroscopy. We found that water pollutants can be degraded with an efficiency ranging from 71 to 100%, for example, by catalysis. Photocatalysis can produce hydrogen from water in higher rate than 100 micromole per hour and up to 88% by metal cracking, while biodiesel production is ranged from 48 to 99% due to different catalysts. Their work is firstly telling what is the case that fossil fuels are depleted as well, and and these and which and further consumption of fossil fuel will only increase mostly greenhouse effect. In other cases, we need to reduce greenhouse effect, and we now need meat materials to replace our energy carrier. Uh, energy carrier substrate, energy carrier taking, and this show us the case is clean energy and synthesize valuable compounds. Environmental catalysis involves developing catalysis to degrade undesirable substances or enable alternative catalytic synthesis of essential molecules, and without generation uh, byproducts which cannot be used. All products of the reaction should be used, and then predict the life length to predict how to again recover and replace. This is the recyclability and life cycle assessment idea. Adsorption is most efficient method for contaminating the environment, however unsatisfying, and the absorption capacity, sluggish equilibrium can make differences. Catalytic systems such as single atom can utilization reduce efficiency to reduce catalyst cost and inherit benefits of different catalysts. The advances in photocatalysis, biocatalysis, and electrolytic catalysis can be provided if we use as the power, as a source of energy of this current energy, photovoltaic solar, wind, and building material of this installation can be made from renewable sources, from organic lignin or metals coming from already mined sources and from lands, because the problems of metals, which are very well, is to make suitable and mining with environment-friendly conditions. Photocatalysis is one of form catalysis, which takes split the organic compound under influence of solar. The many photocatalysts are also mechanical catalysts, so if the mechanical catalysts are steering with them and shearing, then friction energy generates some energy potential that is able to split also some materials, and developed earlier some semiconductive for metal oxide and metal salts. and due to potential also being proposed as potential photocatalyst due to the similar band gap to titanium oxide. In contrast, the chemical stability and environmental toxicity limit the application in environmental remediation. As a result, titanium oxide remains one of the most researched semiconductor photocatalysts in academia and industry, and its photocatalytic properties have been commercialized in air purifying and self-cleaning window system. Although the practical application in water and wastewater treatment is still limited, there were also photocatalytic proportions are for semiconducting and mix of semiconducting polymers and semiconducting and silica oxide, which are not say here, which also has such compound or such ability. They can conduct if the voltage is between the optimal between 10 and 0.08 to 9 to 2 to 9 is the best potential volume potential uh, voltage that is produced a band gap which generates pre-conjunction, which is necessary to conduct and provide current density. The trouble is that the organic materials, polymeric, has wider, but are more expensive, and metals are less, and silica may be less expensive, but the strength is but are strengthened. And the trouble is that not so the polyconjugated polymers, we have still trouble to generate the bioprocess production. So these are the troubles, and this generates another trouble is titanium oxide nanomaterials. Don't titanium oxide with non-metal dopants, sulfur, such as carbon, nitrogen, sulfur, and fluorine. Or metal dopants can narrow the band gap between the valence and conduction bands, thereby enhancing catalytic properties. There has been a growing interest in the development of novel photocatalysts such as zinc oxide. We see that we have biomass volatilization and then that an environmental catalysis are from bioconjugate and can be with mixed with extract of plants make meta-organic, for example, of frameworks or bioinfinity. The applied technology nowadays are solar energy and light emitting diode and chemistry, which is making the the chemistry which are due to motion of kinetics and steering provide some products, and these can be also sustainable for hydrogen production with reducing carbon emission and cleaning water, soil, and air. This is the with simultaneous production of biomass valorization. The uh, the conduction band works that this valence electron, which is between the 0.9 and 2, the best, and up to 3 electron volts, makes proper band gap that will from the electron after light source or light energy of the solar irradiation will jump from last molecular orbital to the highest orbital molecule. And this makes the conjugation and the providing splitting, and the pollutant and water can be bring and and removed, split into hydrogen, water, or other compound like water and carbon dioxide. So this enables pollutant to be utilized. The potential of voltage versus, for example, normal is from cadmium sulfide is 2,4, silicon 1.1, but it's very specific. Mostly is short potential still in compared to polymeric conjugated polymers. The oxide have quite a big potential, but still the potential is due to low spectrum absorption of light, which is very a big advantage of conjugated polymers. This case is problems, and in the case of electrocatalysis, we just have no only electrocatalysis. We just use some metals or conjugated into split due to current. In this case, if electrolysis can be renewable, if the source is renewable, so sun or wind, and can be by photoelectrochemistry, which takes a special photocatalyst will to make electrode and electrodes for this case. The other special case is biocatalysis or microbial electrolysis cell, which using bacteria which splits due to split to digestion of some organic waste, they produce some potential. This potential is enough by themselves to break some compounds like low volatile acid, like ammonia, but is insufficient by themselves to be splitting, for example, water. Therefore, addition of new design of microbial cell with, for example, with metallic oxides anodes, they allows to build such electrode cells. This is circuit that can split water if under giving energy from sun or wind power. The other is biocatalyst is using also can use, for example, different enzymes from yeast or other fungi, animals and bacteria, which can be from cosmetics and pharmaceutics. The lipolytic enzyme are very used, and the waste, for example, coconut meal, and using the penicillin for lipas and urea for maybe from lipids, but lipas are most economically and very important, which is grease waste from olive waste and different agricultural waste. Other is to produce from this daily waste what the slaughterhouse is very important, is very efficient to produce biogas, and common environmental catalysts are carbon to achieve a biomass-based metal organic frameworks, nanocomposite enzymes, and non-noble nanoparticles, commonly used environmental catalysts to achieve sustainability. This other source is, for example, biochar catalysts, so produced for biomass produced from pyrolysis, which are waste, for example. This is char can be also used as catalyst in some cases, and this is for good for catalytic for removal of some metals like chromium and rhodamine, so specific heavy metals, which is very important in case of catastrophe or the places where environmental catastrophe took place to recover the environment. So this char and nitrogen biotopes are very important for remediation of some area to design the regeneration of area which are mostly polluted and destroyed by the human actions. And, for example, the important case would be, for example, Baltic Sea, with the many places of that areas. So to recover fishing, we need to remediate and clean our water very efficiently and very in very types. And other case is that we have released from less hazardous byproducts, good recyclability, energy sufficient process, green application, eco-friendly linkers, and these are general ideas, and these give non-noble metals particles. I talked because we have this extraction plants extract with metal ions in solution, and these, due to capping agents, perform nano-stabilized metallic nanoparticles, which both can be very in wide proportion to have both of polymers and metals. And this is good, big idea, but still needs some some stimulation, some improvement to reduce the risk of heavy metals use or as gold or noble gas or noble metals used applying there to not make to be precisely to not make in to make not dishonest cases which tends to destroy area environment. And this is lactase, another enzyme which is very important for lignin dissolution, and for me is just it. Maybe later I will be talking about it more. Thank you very much for listening to me.